Boys and girls, ladies and gentlemen, we have another session. I would highly recommend you to get in the guides from outside to in if you have access to, because we have AssetMantle's founder, Dipanshu. He'll be, they do a lot of work around the Cosmos ecosystem. So please give up your phones down and clap out loud and welcome Dipanshu.
Hi guys. So today would want to discuss decentralized identifiers. Now that's a topic that I personally have been trying to wrap my head around. It's a little bit complex, but I think like we at AssetMantle have been working towards marrying like distributed ledgers with NFTs and DIDs, and today's talk we're gonna like explore how these three separate topics can work together to create something of a game changer for NFTs, as it says there. So yeah, let's get started. So what are we going to be talking about? We'll talk about decentralized identifiers. Of course, we'll give a quick refresher. So I mean, there are multiple implementations of DIDs out there, and there are multiple interpretations as well. And DID standard itself is something that is like evolving. So like this is something that pertains more towards like what DIDs mean for distributed ledgers, and that's the second topic, DIDs with distributed ledgers. Then we're going to be discussing a little bit about inter-blockchain communication protocol, since we're going to discuss interchain NFTs. That's one of the prerequisites to be able to understand like what's DID, what a DID is going to be enabling for us in the NFT space, in the inter-NFT space. Then we're going to discuss what are the requirements, what would be required to implement this interchain NFT. Then here we're going to be discussing a little bit about marrying the DIDs and NFTs, and like how like the cross between these two concepts would actually flesh out in a real life implementation. And yeah, at AssetMantle we do have an implementation, and we will discuss a little bit about that as well. What does a real world implementation of interchain NFTs with the IDs look like? So yeah, who am I? So yeah, I mean, I've been in in the blockchain space since 2017. I've been building in the Cosmos ecosystem since. I've been building in the Cosmos ecosystem since 2018. Tendermint Core, Consensus Engine, Cosmos SDK. Just like had a look at that, like immediately understood that yeah, this is going to be a game changer for like blockchains in general. We started building on it even before both the Consensus Engine and the chain were even in production. Then I went on to take up a position at as a chief blockchain architect at Comdex's SHIP-5 product. So that was a product that used to tokenize high seas commodity OBLs as NFTs and enable escrow and exchange of these commodities as NFTs back in the day. Like when we started off, we did not even know that tokenized data objects of OBLs could be referred to as NFTs. NFTs was not even a thing back then. But yeah, I mean, it might come out as a little bit of a shocker to some of you guys, but yeah, NFTs can be utilized for a little bit more than trading JPEGs, I guess. So that was the use case that we tried to solve at the Comdex SHIP-5 product. Then went out to co-found and was CTO at Persistence. Built a couple of crazy things there. When we were there, we were able to lead a team to implement world's first interchain NFT transfer in 2019. Since then, I have been leading a working group for pushing the Inter NFT standard towards the standardization track. So this is the standard that kind of incorporates DIDs with NFTs and tries to standardize interchain NFTs through standardization of interface and the metadata link with the NFTs. Currently have founded and building AssetMantle. It's a multi-tenant NFT marketplace that enables creators and enterprise and a host of other use cases to be able to build out their marketplace and be able to enable trade and exchange of these NFTs over chain without deploying any smart contracts or coding anything. You just send transactions to define your class of NFTs and you're all good to go to create your marketplace and send over your NFTs to other blockchains as well. What are decentralized identifiers? I'm sure a majority of you Web3 builders would already be aware of what DIDs are. And there are a couple of crazy projects that are being built around DIDs right now. Some of them are present in this conference as well. So the idea of DIDs, the name itself was coined by the W3C Verifiable Claims Task Force. They were trying to implement cryptographic mechanisms to issue and verify claims, and in doing so they recognized hey, we need identifiers to identify these subjects of these claims that are being sent to or received from. Currently, the DID standard is being pushed towards standardization track and is being maintained and worked on by the W3C DID working group. You can find out more about the current spec of DIDs at the W3C website at W3C DID core. If you do a quick Google search, you'll land up at the specification for it. Again, it's a little bit of a mind bender, and it's been evolving over a period of time. But yeah, I mean, at this particular point of time, it's I guess like a 95% concrete. So what was the main idea behind building these DIDs? What's different about building identifiers that are decentralized? So let's say that your Aadhaar number, right? There might be a database sitting with UIDI somewhere where there is either a random number generator or an incremental number generator that makes an entry inside a database and says, hey, these are the metadata here. And anyone who is wanting to verify that this identity belongs to them would have to come to me and do certain processes to be able to tell me that you are the same person that I issued this document to, and then I will tell the third party that hey, this document belongs to you, which implies that you require UIDI somewhere in here to be able to prove that this identity belongs to you, although the identity has a photograph which anyone can look at and tell that this is you, right? So the main aim of DIDs were to be able to create an identifier that anyone can generate on their own, and not only that, without requiring a centralized entity be able to verify the control that they control this particular identifier, that they are the owner or the controller of this particular identifier. Now that might seem like a simple task, but it's quite complex when we get down to the exact implementation and details of it. So the design goal, the goal was big, and currently the implementation picks UUIDs as the default mode for generating DIDs. Now you might ask, hey, how is it different from a centralized entity generating a unique identifier from some randomness, right? That's true, and there are multiple implementations of DIDs where you utilize the metadata, the immutables in the metadata of your identifier to generate the DID itself. But yeah, using UUID, I guess is the easiest way of generating an identifier that you do not require a centralized entity for. The space, the randomness space in which UUIDs are created is so vast that if you were to go ahead and generate one for yourself, you would not require a centralized entity to ensure that there is not a clash happening somewhere in the database, right? And for the DID document itself, they picked JSON LD. So that's about the standard, like the current like base version of the standard. But yeah, for a quick refresher, let's go through some of the terms that like a DID refers to. So DID, if I had to put it like in a very basic language, would be something like a URI that you generate yourself, and there is no like a domain name registry somewhere. It's generated and by you, and you verify the ownership through a cryptographic mechanism. So the identifier itself is not the subject itself. So like if someone said that DID of a person was the person, no, that's not true. DID is just a URI which points towards a document. Now this document contains the metadata linked to the identifier, and this document is defining the subject, which is the subject of the DID. So to put it like this, like it would be something like saying that uidi.com / your username is not you. It's a URI pointing towards a document, which is, let's say, your Aadhaar card, which is the DID document in this scenario, which contains metadata that is trying to define you. But you are the subject of DID is not captured by either the document or the DID or the DID URI. The subject remains outside the foundations of definitions of DID, except for scenarios in which the subject is like piece of data itself. So if the document is meta, if the document is defining itself, for example, let's say an NFT, then in that scenario, the subject is the DID document itself. So yeah, that's one of the reasons why I say like DIDs are very well suited for like defining NFTs. Although the first use case that comes to mind is defining like wallets for people. We'll come to wallets later. Then we have the controller and resolver. So the document, since it's being not issued by a centralized entity, who is it that controls the mutation? Who is it that controls the capabilities defined on this DID, like CRUD maybe, on this document? So it's the controller of the document, and the controller or the owner or sometimes the subject might be the controller of the document, utilizes cryptographic mechanisms to prove that yes, I control this document, authenticate, authorize, and execute the CRUD capabilities on top of the document. And then we have the DID resolver. So although DIDs do not require a centralized entity to like prove ownership or verify, authenticate, authorize who is the controller, they do require verifiable data source where you store the DID and you're able to like fetch it. So a resolver is like kind of like a DNS resolver, where you just put in the DID URI and you get back the document. And when you type in google.com, that's kind of the DID URI in this analogy, and you get back HTML, which is the website for google.com, which is kind of the DID document. So a resolver is kind of like your URI resolver in this scenario. So that's about DIDs. There's a lot more to discuss about DIDs, but there's just a refresher for those who might already be aware of it and wanted to just refresh their memories, I guess. Our DIDs were not designed to be like with distributed ledgers in mind, but if you think about it, like DIDs and distributed ledgers are kind of like meant for each other, right? So let's look at how like your wallet or your identification is being done right now on a distributed ledger of your choice. For example, let's say Ethereum. So you are being identified by like an address that is created from like a public-private cryptographic key pair. So those are called CIDs, cryptographic identifiers, right? Cryptographic identifiers, the design goal for cryptographic identifiers are very similar to DIDs, which is that anyone should be able to generate an identifier, and that identifier must have some linkages to a cryptographic method that you utilize to verify ownership over that identifier. So for example, the way you generate a CID is you utilize a seed phrase or mnemonic, and you generate a public-private key pair. Now this public-private key pair you can utilize to derive an address. This address on a distributed ledger is linked to your wallet, and the way you prove ownership or control over this particular identifier is through the private key. You utilize the private key to sign credentials, sign transactions, and to prove that you own this particular CID. So if we look at the design goals, if we look at the way CIDs are created and the ownership is verified, it's very close to how DIDs do it. But DIDs are kind of like the superset of what CID functionality is. So right now, many of you might have faced this issue that if you were to lose the mnemonic or seed phrase that you utilize to create the CID, you lose ownership, and you lose if that address was linked with your identity in some way, you end up losing your identity, right? So yeah, that's not great. Like a seed phrase or a mnemonic should not be linked to your identity. Your identity is not as ephemeral as seed phrase, right? So what DIDs do, what DID does, and it's very similar to what CIDs like your Ethereum address do, is they utilize a bunch of metadata, and a piece of that metadata is authentication. Authentication may contain CIDs, so that's what I meant by when I said that DIDs are a superset. CIDs are kind of like the subset of functionalities of decentralized identifiers. And you take a DID document, you take a bunch of metadata, you utilize it to generate the DID URI. The DID URI refers to the DID subject, and the way you verify ownership or verify control over the DID is through a capability inside the DID document itself, which is the DID auth method. So yeah, I mean, I tried to put it in like representation that we can look at it and try to compare contrast between what CIDs and DIDs do. Of course, the comparison is not as simple as mentioned here, but yeah, I mean it's quite close to what we're trying to achieve. So yeah, I mean that naturally brings about the question, hey, if CIDs and DIDs are so close and DIDs enable much more capabilities, a superset of functionality that CIDs do, why can't I utilize it on a distributed ledger? You absolutely can, and that's why I say that DIDs may as well be like a future for identity and wallets and even NFTs, which we're going to discuss next on distributed ledgers. There are caveats though. There are caveats with DID. So for a CID to exist, you do not need a distributed ledger. You do not need a verifiable data source. You can generate your address. You can generate your public-private key pair offline and never send transactions through it, and you would still maintain that identifier that you may not utilize on a ledger. You might just utilize it to sign, let's say, PDFs, right? So for a CID to exist, you do not need a distributed ledger. It exists on its own. But for a DID, you do need a verifiable data registry. You do need something like a DLT or something like a centralized data registry to exist. So, but instead of considering it a disadvantage, we can think of it as like a given. If you're utilizing a DID on the top of a distributed ledger, you already have the prerequisite of having DIDs, that is a verifiable data registry, which is a DLT or a blockchain. So yeah, they go together very well, right? That's what I think as well. But next piece of the puzzle, the next piece of the puzzle that we need to understand, and I'm just going to quickly go through it. I'm very sure that majority of us will be aware of it. I'm not even going to explain how they work. But for interchain NFTs to work, we also need an interchain communication protocol of some sort, right? You require, if an NFT exists across two chains, you do require a way for one chain to communicate metadata or transactions about this NFT from one to the other, right? So, yeah, the design goal for blockchain communication, inter-blockchain communication protocol would be to enable transactionally sending, receiving of messages that is verifiable by the state machine of either of the DLTs. So except for the proof part, like message passing is something that we are all very aware of, right? Just add verification and you have a blockchain communication protocol. Sounds simple, right? It's not that simple. We as far as I know, we currently just have two inter-blockchain communication protocol. None of them are general purpose. We have Polkadot cross-chain messaging, message passing, CMP, and we have Cosmos's IBC. Now, IBC is the one that is more permissionless and allows for protocol-like definition that can be implemented across different chains and protocols. But yeah, it is still not general purpose. It is only restricted to currently passing around messages about only send coin transactions, and it's not a general purpose message passing inter-blockchain communication protocol yet. But these are the contenders that we have, and we would require these to build inter-blockchain NFT. Right? Having defined the base terms, having defined the DIDs, having defined what DIDs do with the distributed ledgers, having defined inter-blockchain communication protocols, what would, if you were to go ahead and design NFT, an interchain NFT, what would you require? What is it at the end of the day would be the base requirements to enable the functionalities of an inter-blockchain NFT. First of all, of course, you would require a verifiable data registry. You would require some place to store the metadata. The issuer of the NFTs would ultimately have to store this metadata somewhere that is verifiable. So that we have out of the way already, right? We have a lot of blockchains that are storing NFTs at this particular point of time. After we have ensured that we have a verifiable data registry for the NFT metadata, we would require a way, if this NFT is to be passed on to a different chain, if it is to be passed on from issuer to an acquirer chain, we would require a way for the acquirer chain to be able to access the metadata for this NFT. Now, would such implementation mean that I need to transfer over the metadata of the NFT to a different chain? I would say no, because you might be able to transfer the metadata of the NFT, but then that creates a lot of issues with resolution, that creates a lot of resolution with source of authority, that creates a lot of issues with who ultimately is the controller of this NFT and is the execution of the capabilities on top of this NFTs, capabilities like CRUD being done in a proper fashion or not, right? So I would say transferring over the metadata of the NFT directly over to the acquirer chain, maybe not the best way, a lot of issues with it. Instead, what we can do is give the acquirer chain a way to A, resolve or query the metadata, and B, cryptographically verify if the metadata is correct, if the metadata is committed into the state of the issuer chain or not, right? So that way the metadata never gets transferred over to the acquirer chain, only the capability to query and verify the correctness of this data is exported to the, or is required at the acquirer chain's end, right? So reiterating, we require a place to store the metadata initially. We then require a methodology for the NFT to be sent over to another chain to have the acquirer chain query or access the metadata for this interchain NFT that we're talking about. After we have transferred over the metadata, we would want to operationalize some of the capabilities that would be accessing this metadata. So for example, let's say I have an NFT that would be locked for transfer for n number of blocks, right? I need that metadata to be on chain A to be able to fetch, and B, then I have to operationalize that transfer block functionality, the transfer block capability as well, right? So the acquired chain would have to have a mechanism for it to be able to not only access the metadata, but also like block a transfer that is being done on an NFT whose metadata says that it is blocked for transfer still n block, and that information is present as metadata on top of that NFT in the issuer chain, right? After then, given that you have the data, given that you can access the data, given that you can operationalize the data, you require a methodology, you require the capability to be able to verify if the person who is trying to access this capability on the acquired chain is the actual person that is authenticated, that is that is authorized and can be authenticated to be him to operationalize this capability on the acquired chain. So yeah, we have data, we have way to access the data, we have way to operationalize capabilities, and we have a mechanism to authorize, authenticate the actor that is trying to invoke the capability. We require all of these. So do we have all of these components required? Do we have all of these pieces required to piece together and make an interchain NFT? Yes, we do, and that's what we've been discussing. We can utilize DIDs, we can utilize DLTs to store the data. We can use DIDs and DID URI resolution to query the metadata. We can utilize the authentication properties of the DID to be able to authenticate the person who is trying to invoke the capability on the acquired chain. So yeah, we do have all the components. So how would an NFT like this look like? If someone went out and built this NFT, if someone took the NFT operationalization and metadata standardization aspect and mapped it to DID methods and documents, so you can view DID NFT operationalization, you can link it to DID methods. You have metadata standardization, and you can define a document schema. If we map them and we implemented an interchain NFT, what would be the capabilities that this, what would be the use cases this NFT be able to make possible, right? So of course, you'd be able to transfer over this NFTs referred to by the DID URI to another chain's CID wallet, even if they do not implement DID, even if they do not have DID capabilities. You can just utilize the DID URI and mention it as the denom of the coin type that the CID wallet might be able to recognize and transfer it over to other chain. Secondarily, you'd be able to define a secure mutation logic, secure way to operationalize the let's say CRUD capabilities on this NFT. Of course, since the metadata is sitting and the logic is sitting on the issuer chain, you don't need to export this capability to the acquirer chain. You can have this logic be present at the issuer chain itself. Let it be the source of trust. Let it be the source of authority on who gets to mutate and which is the true source of information on the NFT. And let the acquirer chain just query this data, and issuer chain operationalize the CRUD capabilities, for example. Then of course you'd be able to like query, and you'd be able to like get the metadata about this NFT across a chain and utilize it for like without requiring an oracle, observing NFTs and enabling like all different kinds of applications one can imagine. You would also have, since you have like standardized the metadata and you have standardized the methods, you can then like go ahead and say that, hey, I don't require 15 smart contracts to store the different like schemas of metadata, and I do not require 15 different smart contracts to tell me what this NFT can do. If I have a standardized way to represent the metadata, if I have a standardized way to represent the methods, I can then just implement a singular CID based wallet, for example, to store all of this NFT. So I don't need to go ahead and query like 15,000 different smart contracts to tell which one contains an NFT that belongs to me. I can just hold all of these NFTs from different classes of NFTs in just one wallet. And not only different classes of NFTs on one chain, you can hold like NFTs from different chains in one CID based wallet as well. Since the metadata is unified, there's a standardized schema for the metadata of this NFT. You can also imagine GUI components that will be able to like take in the standardized document and be able to churn out a GUI output GUI representation of the NFT that is standard across wherever you're trying to represent this NFT. So it won't be the case that for you to be able to view an NFT, you just need to go over to the web app where the issuance of the NFT happen. You can literally like have this NFT and have it be represented in like any wallet and any web app, and it will all look the same. Since the metadata is standardized, you can go ahead and standardize the way the GUI of this particular NFT looks like. So that's a crazy set of like functionalities that might get enabled if we go ahead and implement interchain NFTs with DIDs, right? So yeah, I mean, I'll discuss a little bit about our implementation that we have gone on and did. We just utilize all of these concepts, and I asked you about if the components for each of these problems are present, and yeah, these are the components that we utilize to define our interchain NFT. For consensus, we utilize DPoS, Tendermint Core consensus engine. For the metadata and the method standardization, we utilize the inter-NFT standard. The working group for this particular standard is live, and we are trying to push, and we're still like trying to figure out the like exact details of this, how this standard would look like. But we do have a working implementation of inter-NFT. We utilize inter-identities to operationalize DID-based wallets, which would not you would not lose access to if you lost, like let's say mnemonics. You would not lose your identity if you lost your mnemonics, etc. You can rotate the CIDs inside the DID, and you can utilize one identity to like access your wallet. We have IBC. We utilize IBC, inter-blockchain communication protocol, for the transfers, inter-blockchain transfers, and the resolution aspect is something that is still being developed. But yeah, for now, transfers are enabled through IBC. In future, we will be able to like query and resolve this DID metadata over the protocol as well. And then we have the mantle module. So to be able to export some of the operationalization capabilities to the acquirer chain, we have built out these modular modules that we call them mantle modules that anyone can import inside the chain and be able to operationalize the capabilities of this interchain NFT. that's about interchain NFT. That's about DIDs and how we can utilize it to enable these crazy use cases. If you'd want to connect with us, you can head over to this. You can head over to Twitter. You can head over to Telegram and like ping us there. If you'd want to join the working group, we'll be like glad to have you. And yeah, thanks for being such a nice audience. I do have a bonus meme for you guys for being nice audience. Yeah.
Thank you.